Hello, welcome to this session on human-computer interaction design principles. We will take a look at some of the everyday things and find out some principles which govern the user interface design. If we take a look at how do we use everyday things, we will see that many times we see digital watches which cannot be configured, plastic wrapped packages which do not open, washing machines and dryers too confusing to use, DVD TV do not work properly, doors that do not open. So what we see is well-designed objects are easy to interpret and understand, and they contain some visible clues. So there is a design principles which are actually behind a good user interface. And as according to Donald Norman, there are six design principles which are visibility, affordance, natural mapping, constraints, conceptual model, and feedback. We will take a look at each of these and we will see how this uh, play a part in coming up with a better user interface. So, if you want to see this, like how these design principles are applied by performing a task, then we'll be able to appreciate their role. Let us say the user decides he needs to perform a task. When he wants to perform this task, he should identify the feature that he can use to perform the task. This is provided by visibility principle. He need to determine how those features are used. Affordance comes into picture at this stage. He need to understand how the feature performs the task. This relates to mapping. There might be some constraints which will prevent the user from committing error. So he should know what to select or enter. So that is allowed by constraints. He should also, while doing this thing, should predict what the program will do, which is governed by conceptual model, and he should be able to interpret the result. That is what we call as feedback. So the six principles, if you see, they come into picture at some of the other stage when people are performing the task. So the first design principle, visibility, which gives the user the ability to figure out how to use something just by looking at it. Let us take a look at it. Visibility means the correct part must be visible and must convey the correct message. For example, doors. When you take a look at doors, they naturally indicate where to push or pull. But when there are problems in visibility, it is because of lack of clues or no mapping. For example, let's say we have only one button on the wall to control two things, like say fan and a tube light. Then we won't understand that putting it on means tube light is on, putting it off means fan is off, or something of that sort. So you can also take a look at new telephones, digital telephones, which provide very poor visibility because same button, same key can actually mean lot of have lot of functionality. This also happens with mobile phones. It has to be also noted that excess of visibility leads to intimidating design. For example, in a cockpit of a plane, if you keep a lot of user interface elements, that will be an intimidating thing to a pilot. So sometimes less is also better. Coming to the second principle, which is affordance, which can be stated as which involves the perceived and actual properties of an object that suggest how the object is to be used. You can take a look at this chair. Chair, whenever we look at a chair, it means people can sit on it. So we perceive, and based on our experience, we know that chairs are meant to sit. Doors are meant to be opened. Now, based on how the door levers or handles are placed, people can guess or people can perceive whether I have to push the door or whether I have to pull the door. So affordances provide strong clues to the operation of things. What it means is doors are for opening, doorbell is for pressing, glass is for breaking. So actually there's a psychology of causality which is also at work. You can take this example of how visibility and affordance play together. You can take an example of a command button and a hyperlink. So command button, when you take a look at command button, it has a raised borders and people know that it has to be clicked. Hyperlink, when you see on a web page, is something, let's say, different from the other text, and people know that it has to be clicked. Now, these type of clues which are there may not be, may people may have not realized that we have to do such actions based on their prior, let's say, experiences. But certain standards have asked, or certain standards are mandated that you need to do this. So then that becomes part of the affordance. You can see this different types of windows, different types of dialog boxes, different types of buttons, and by looking at them, they offer some affordance, and one should realize what can be done with them. So the third design principle, natural mapping, creates a clear relationship between what the user wants to do and the mechanism for doing it. For example, take a look at this gas stove with four burners and four knobs. Now, how do we know which knob controls which burner? So there is no clear relationship between a burner and a stove. So instead of that, you take a look at this particular stove, which is much better designed because there is a clear indication that which knob controls which particular gas stove, gas burner. Mapping also could be based on your physical knowledge of physical law or laws of physics. If you turn your wheel in one side, the car also should turn in the same side. That gives you assurance that things are working in perfect or in the proper manner. So the mapping means perception of the relationship between the controller and the car control. You can also have physical laws of physics, physical resemblance, which can be used in mapping. Like say, if, a face of a man in front of a washroom will tell that this particular washroom is meant for man. There could be a spatial mapping, the switches and the layout of a room from which you can also understand many things. There could be cultural mapping. Sometimes some cultural mapping which don't work are based on color, taste, location, musical pitch, all over. There could be also biological attributes of human anatomy. And then there are some certain standards based on which everybody tries to use the same standard, like say keyboard standard. So the fourth design principle, constraints, works along with natural mapping and other principles to reduce the number of ways to perform a task and amount of knowledge needed to perform a task. What it means is, rather than storing knowledge about how to handle any device, it is better that that knowledge is actually present in the world or it is in the device and people can explore. So good constraints eliminate invalid choices while making the remaining valid choices easier to use. It also eliminates the need for error messages. By looking at this scissor, one will know where to insert thumb and where to insert other fingers, because the size of the two holes is uneven. But take a look at a surgical scissor. It doesn't matter how you use it or which fingers you use it, but it can be used. And it also cannot be used on very big objects. You can also see these examples of constraints like male-female connectors, forcing type of functions, which are also type of constraints, so that unless you put key in your ignition slot and you turn it on, car will not start, and then you cannot take the key out. There are also interdependent constraints, like if somebody uses a lavatory, then the indicator light should be on. So that is connected to each other. So these are called as interlocks. You can also see another example of that. Then there are logical constraints, so that this thing will fit only into that particular slot. The fifth design principle is the conceptual model, where user build a certain type of a working model of the system in their head. It need not be necessarily the correct model of that thing, but this will be useful to predict the result according to the user. When you take a look at this bicycle, based on your knowledge of physics and all other laws, people create a conceptual model of it. They try to imagine that somebody is riding on this bicycle and then they predict that this will not work. So if you see, sometimes conceptual model of a thing is very simple, but if you take a look at a digital watch which has multiple functionalities, it is difficult for people to explain how a digital watch functions and shows time. So what is required is a good conceptual model. So it is one in which the user's understanding of how something works corresponds to the way it actually works. This requires that principles of operation be observable, all actions be consistent with the conceptual model, and visible part of a device reflect the current state of the device in a way consistent with that model. You can have many different types of conceptual model. Right now we will not go into this. The last design principle, feedback, which indicates that the task is being done and being done correctly, is also important. When we talk about feedback, what it means is user gets assurance that the command has worked. It can also mean that system has given error messages. And what is important to know is good feedback is immediate and obvious.